Distinguished ladies and gentlemen, today we are focusing our discussions on chemistry, and particularly we are discussing this topic, organic chemistry. Now, basically, chemistry is subdivided into three categories. We have what is called physical chemistry, we have what is called inorganic chemistry, and we have what is called organic chemistry. So today we begin by discussing this topic. Now let me start by defining organic chemistry. You see, initially organic chemistry was defined as the chemistry of carbon and its compounds. Chemistry of carbon and its compounds. This was the initial definition given for organic chemistry. So when we study carbon and we study compounds of carbon, what we are dealing with is organic chemistry, according to the first definition. But after giving this definition, later discoveries emerged, and compounds of carbon were later discovered that were not organic compounds. We have three classes of compounds of carbon that were discovered after the first definition. The first class of compounds of carbon is metallic carbides. Very good examples are calcium carbide, we have lead carbide. These compounds were discovered after the first definition, and these compounds are also compounds of carbon, but these compounds are not organic. Another class of compounds of carbon are carbon oxides, like carbon dioxide and carbon monoxide. Then we have trioxocarbonates 4. Like calcium trioxocarbonate, like sodium trioxocarbonate, like potassium trioxocarbonate. Now, these compounds were discovered after the first definition, and all of them are compounds of carbon, but none of these compounds is organic compound. Therefore, the discovery of these three classes of compounds of carbon now contradicted the first definition of organic chemistry given, because the first definition says the study of carbon and its compounds is organic chemistry, meaning all compounds of carbon are organic compounds. But these three classes were discovered and they are still compounds of carbon, but they are not organic compounds. So due to that, the definition was later modified, it was amended. And the person that amended that definition was a scientist known as Markovnikov. He redefined organic chemistry after the discovery of these three classes of compounds of carbon that contradicted the first definition. So what this man said now is, he redefined organic chemistry as the chemistry of carbon and its compounds, excluding metallic carbides, carbon oxides, and trioxocarbonates 4. This means that this man still repeated the definition given initially. So what he included was, he now excluded these three classes of compounds that were discovered that were not organic compounds. So the first definition is now amended into organic chemistry is the chemistry of carbon and its compounds, excluding metallic carbides, carbon oxides, trioxocarbonates 4. Now, we have two definitions, the first one and the second one. We say the first one had an error because of this discovery, and the second one corrected the error. But now we have another definition that is widely accepted as the definition for organic chemistry. And the most accepted definition, they call it the modern definition. Modern definition of organic chemistry. So the modern definition of organic chemistry says organic chemistry is the study of hydrocarbons and their derivatives. Study of hydrocarbon and their derivatives is the modern definition of organic chemistry. So organic chemistry is the chemistry of hydrocarbons and their derivatives. Now, if I want to understand the real meaning of organic chemistry, I must understand what is hydrocarbon and what are the derivatives of hydrocarbons. Now, when we say hydrocarbon, hydrocarbons are compounds that are made up of hydrogen and carbon only. Compounds made up of hydrogen and carbon only are called hydrocarbons. Hydro is referring to hydrogen, and of course carbon is referring to this carbon. So any compound that contains carbon and hydrogen only, that compound is said to be a hydrocarbon. Now, if hydrocarbon are compounds that have carbon and hydrogen only, and now we add a different element to this compound that is neither carbon nor hydrogen, so the new compound we are producing now is the derivative of hydrocarbon. Hydrocarbons have only carbon and hydrogen, but anytime we add a different element to the compound that is neither carbon nor hydrogen, like oxygen in this case, so this is no longer hydrocarbon because of the additional element you have. So now we call this one derivative of hydrocarbon. So the study of compounds that have carbon and hydrogen only, and the study of compounds that have carbon, hydrogen and other elements is what is referred to organic chemistry. So hydrocarbons are compounds that have carbon and hydrogen only. Then derivatives of hydrocarbons are compounds that have carbon, hydrogen and other elements. So now let's take hydrocarbon as a topic and explain. Now we say hydrocarbons are compounds that contain carbon and hydrogen only, with no any other element. Okay, the general molecular formula for hydrocarbon is CXHY, where X and Y are whole numbers. And X is either less than or equal to Y. We say hydrocarbons are compounds that contain carbon and hydrogen only, and the general molecular formula for hydrocarbon is CXHY. This X is representing number of carbons and the Y is representing number of hydrogen. So CXHY is the general formula representing hydrocarbons. And we see these X and Y are whole numbers, they are not fractions, they are whole numbers. And this X is either less than Y or equal to Y. For instance, if I have C2H6 or I have C3H8, in these two compounds, my X is 2 here and my Y is 6. In this one, my X is 3, my Y is 8. So if you observe, our X is less than our Y. 2 is less than 6 and 3 is less than 8. But if you look at compounds like C2H2 or C6H6, my X here is 2, my Y is 2. My X here is 6, my Y is 6. So in these two compounds, you see that my X is equal to my Y. So this is why we say X is either less than Y or equal to Y. But X can never be greater than Y. X can never be greater than Y. It is either less than Y or equal to Y. Now let's look at classification of these compounds, hydrocarbons. Okay, now hydrocarbons are divided into two classes. We have acyclic compounds and we have cyclic compounds. The acyclic compounds are compounds that exist in straight chain. Compounds that exist in straight chain like this, they are called acyclic compounds. But compounds that exist in cyclic form, we call them cyclic hydrocarbons. So cyclic hydrocarbons exist in cyclic form, acyclic hydrocarbons exist in straight form, which is the opposite of this one. Now, the acyclic hydrocarbons is further subdivided into two. We have what is called aliphatic hydrocarbons, and we have what is called aromatic hydrocarbons. Then the aliphatic is also divided into three. We have what is called alkanes, we have what is called alkenes, and we have what is called alkynes. Then the cyclic hydrocarbons are also subdivided into three. We have what is called cycloalkanes, we have what is called cycloalkenes, and we have what is called alicyclic. So this is the classification of hydrocarbons. Now, for me to understand the whole of this topic, I need to know the individual classifications here. We need to know what are alkenes, alkenes, and alkynes. If we are able to know these three, then we are done with aliphatic hydrocarbon. Then if we discuss aromatic, and now we have discussed aliphatic, so we can say we are done with acyclic hydrocarbons. While in this part, we need to discuss cycloalkanes, cycloalkenes, and alicyclic compounds. Then we are done with cyclic hydrocarbons. So let's take them one after the other. We begin with the first one, which is alkanes. Now, what are alkanes? You see, an alternative name to alkanes is paraffin. Paraffin means little affinity. Little affinity or little reactivity. Meaning these compounds have little affinity or little reactivity. So an alternative name to alkanes is paraffin. Now when we say alkanes, alkanes are saturated hydrocarbons. They are saturated hydrocarbons with the general molecular formula CnH2n plus 2. We say alkanes are saturated hydrocarbons with the general molecular formula CnH2n plus 2, where this N represents number of carbons. N represents number of carbons. Now we have what is called alkane group or alkane family, where we can use this formula to derive the molecular formula of all members of the alkane. We call that group alkane group or alkane family. Let's look at them. Now the alkane family or alkane group, we have plenty compounds that form the alkane group, but we are going to restrict our definitions or our explanations on the first 10 members. The first one is called methane. The second one is called ethane. The third one is called propane. Fourth one is called butane. Fifth one is called pentane. The sixth is called hexane. The seventh is called heptane. Eight is called octane. 9 is called nonane. And the 10th one is called decane. So these are the alkane members or alkane group or alkane family. Now if I want to derive the molecular formula of these compounds, I use the formula we said is the general molecular formula for alkane, which is CnH2n plus 2. And we say this N is number of carbons. So this number I'm writing besides these names represents the number of carbons of the compounds, meaning methane has 1 carbon, ethane has 2 carbons, propane 3, butane 4, pentane 5, down to decane that has 10. So these numbers represent our number of carbons, which is our N. So it means in methane our N is equal to 1. So if N is 1, using this formula, meaning I have C1 H2 times 1 plus 2. So C1 H2 times 1 plus 2, using this formula. So my 2 times 1 is 2 plus 2, 4. So I have C1 H4. So the formula for methane is CH4, using this formula. So methane is CH4. Ethane, in ethane N is equal to 2. Therefore I have C2 H2 times 2 plus 2. So this gives me C2 H6, using the same formula. For propane, N is equal to 3. So I have C3 H2 times 3 plus 2, which is C3 H8. So when I continue, I can arrive at their molecular formula using the same general molecular formula for alkane. So if I use the same method for butane, I will have C4 H10. This will give me C5 H12, C6 H14, C7 H16, C8 H18, C9 H20, and C10 H22. So this is how I calculate my molecular formula of each compound using the general molecular alkanes. Okay, now that we have seen their molecular formula, let's assume we are asked to write or to draw the structure of this compound. How do they look like? Now, for instance, if I have CH4, which is methane, the first member, the structure for each CH4 is 1 carbon and 4 hydrogens. So this is how we write the structure of methane: 1 carbon, 4 hydrogens. The second member, which is C2H6, meaning I have 2 carbons and I have 6 hydrogens. So this is the structure of ethane. So I can use the same format to write all the structures of the compounds using the same format. You write the carbon chains, then you circle everything by the number of hydrogens you have. Okay, now having seen the structure, we said alkanes are saturated hydrocarbons. Alkanes are saturated hydrocarbons. So let's look at the meaning of the word saturation. Why are they saturated? Now, we have 2 definitions for saturation. We have a first definition, we have a second definition. So let's explain the 2 definitions and see what saturation means. Now, some textbooks or some scientists define saturation as, they say a compound is said to be saturated if throughout the chain of the compound there is single bond between carbon and the next carbon. Meaning, if I have a compound that has plenty carbons, that this compound is said to be saturated if between 1 carbon and the next carbon there is a single bond. Between 1 carbon and the next carbon there is a single bond. Between 1 carbon and the next carbon there is a single bond throughout the chain of the compound. Any compound that has this property is said to be saturated compound, according to the first definition. So a compound is said to be saturated if there is a single bond between the carbon atoms throughout the chain. Now the second definition says a compound is said to be saturated if each carbon atom is bonded by 4 different atoms. A compound is said to be saturated if each carbon atom is bonded by 4 different atoms. For instance, this carbon is bonded by 1, 2, 3, 4 bonds. The next carbon is bonded by 1, 2, 3, 4 bonds. The next carbon is bonded by 1, 2, 3 bonds. So according to the second definition, a compound is said to be saturated if each carbon atom is bonded by 4 different atoms throughout the chain. Throughout the chain, every carbon atom is bonded by 4 different atoms, then the compound is said to be saturated. Now, if we look at these two definitions closely, we get to understand that both definitions are correct. The only thing I observed is that one definition is more correct than the other one. For instance, if I'm asked to explain whether methane is a saturated compound or not based on these two definitions. Now, if I use this definition to confirm whether methane is saturated or not, because methane of course is saturated because it is the first member of alkenes. Okay, let's see if this definition explains the saturation of methane. This definition says a compound is said to be saturated if there is single bond between carbon atoms. Single bond between one carbon atom and the next carbon atom. But methane is a compound that has only one carbon, and this says there must be single bond between one carbon and the next carbon. It means this definition cannot explain the saturation of methane. If we need more than one carbon to know whether there is single bond between them or not, so we cannot explain the saturation of methane because methane has only one carbon. Okay, let's look at the second definition. This one says a compound is said to be saturated if each carbon atom is bonded by 4 different atoms. Each carbon atom is bonded by 4 different atoms. So if you look at methane, we have a carbon, and this carbon is bonded by 1, 2, 3, 4 different atoms. So based on the second definition, methane is saturated. But based on the first definition, we do not know the status of methane. So this means that the second definition is more correct than the first definition. Why? Because you cannot explain the saturation of methane with the first definition, but you can explain the saturation of methane with the second definition. Meaning this definition does not accept any saturated compound, but this definition includes all saturated compounds except methane. Now, provided we accept one saturated compound from this definition, so this definition is not as correct as the second definition. So this is the meaning of saturation. Okay. Now this is where we stop in this video. So in the next video we continue from where we stop.